Welcome to AwesomeDOT, your dedicated guide to the Polkadot and Kusama ecosystem. All content is thoughtfully curated for educational and informational purposes. We ensure that our resources reflect the latest developments and insights. We prioritize your knowledge without offering financial advice or endorsing the buying, selling, or holding of tokens. The opinions and resources shared are those of the respective contributors and do not reflect the official stance of AwesomeDOT. Trust in your discretion for all financial decisions inspired by our content.
So, hello everyone. Welcome to the seventh episode of the AwesomeDOT Podcast. I'm your host Yogesh, and today we are joined by Kamil from the Quadrivium team. Kamil holds an MSc in computer science, and he has been involved in the Polkadot ecosystem for over 8 years now. He has been working on Kagome, a Polkadot host implementation in C++. Welcome to the podcast, Kamil. How are you?
Yeah, hey. Yeah, good. How are you?
All good, all good. So, okay. So before we dive deeper into Kagome, I wanted to sort of just start off with a bit of your background and just understand how you got into crypto. So can you tell us a bit about how you first sort of discovered crypto and what motivated you to get into it?
Yeah, sure. I think it was when I was studying in my university. It was in Innopolis in Tatarstan region in Russia. And yeah, back then, one of my friends, he actually shared the vacation. Well, basically, there was a position in Suramitsu to work as C++ developer. So I applied and joined Suramitsu. And back then, Suramitsu was working on a blockchain called Hyperledger Iroha. And in Innopolis University, we basically created a team that would work first in implementation of database for this blockchain and then on the blockchain itself. And after that, Suramitsu grew quite a lot. So we started working in other ecosystems like Polkadot, for example. There were also projects in Filecoin. We were developing P2P. That's how I started in blockchain and how I got involved in Iroha first, and then we started Kagome.
Nice. Okay. So then how did you come down to sort of working on Polkadot? Like you started off with Hyperledger, and then what made you move to Polkadot itself?
Yeah, sure. So the Kagome project itself, it started in Suramitsu. When the Polkadot itself just was getting started, just long before the mainnet was launched, there was an idea that the Polkadot should have multiple clients implementations, kind of the same thing what we have in Ethereum, because obviously Polkadot has the same founders as Ethereum, Gavin Wood, and that's why I think Web3 Foundation they started searching for teams who would be who would join this initiative so that they can implement the Polkadot node in other languages following the Polkadot protocol. And that's how they found Suramitsu, and Suramitsu was accepted as one of implementer of the Polkadot node. What we call now Polkadot host. And that's how, because I was working in Suramitsu, I was offered the position of team lead of this project, and that's how we started working on Kagome and Polkadot.
Nice. Okay, interesting. So what was like early development in Polkadot looked like, right? Because you were there from the very beginning in that sense.
Back then, in the beginning it was very challenging. I think it's still quite challenging, but in the beginning we kind of we didn't know what to expect, where to search different resources to kind of learn how Polkadot protocol works. I think when we were getting started with Kagome, it was, I think, the end of 2018. Web3 Foundation just was getting started working on specification for Polkadot. We basically followed this protocol, this specification to implement Polkadot protocol. And the idea was that we should not follow what is being implemented in Rust, in what we call now Polkadot SDK, which was just Substrate back then. Because that way, if we just copied the Rust code and re-implemented it in C++, the language in which Kagome project is written, then we would have the same bugs as we have in Substrate. So instead, we only followed the specification, and well, that was challenging, because when we finished implementing everything that we had in specification, and then we started working on compatibility, a lot of things didn't work as expected, and then we had to dig into Rust code of the original implementation and kind of try to understand basically, what are incompatibilities between the Rust implementation and the specification, and we found quite a few very important differences. So yeah, that's basically was the process. So we had specification, we implemented things, that then we check for compatibility, we go to Rust code, try to understand what's going on there, then apply some fixes. I think we still do something like that, but now we have many things that actually help us, like RFCs. The release notes in Polkadot SDK are more clear for us now, and we are more familiar with their code. And so yeah, that was the experience back then.
Interesting. Okay, so so then how do you tackle with so new and new things keep coming to Polkadot, right? It's like an endless stream of things that keep coming. So how do you sort of keep up?
Yeah, right. That's one of the most challenging thing, because for example, we launched our Western validator using Kagome, I think more than a year ago, and it worked perfectly. But then the async backing was introduced, and we didn't have its implementation, so Kagome was not able to validate parachains anymore. So yeah, we kind of need to keep up and implement the new stuff that's coming as fast as possible. So to do that, we follow, as I said, like RFC process is very helpful. The release notes of Polkadot SDK, we also follow them a lot. We should understand that the things that we need to catch up with original implementation in Rust, they should be related to protocol itself, because sometimes there are changes that are not protocol specific. Like, for example, if Polkadot SDK decided to replace database, it doesn't matter for us. That's only change that affecting the Polkadot SDK nodes. But if they're updating, for example, how backing is working or how sync protocol is working, we should follow that. And the idea with RFC process was that whenever we have any change to the Polkadot protocol, they should be documented in RFC, and they should be accepted by the Polkadot fellowship. This, in most cases, it works perfectly, but sometimes we see that Polkadot SDK has changes that protocol specific, and they are not reflected in the RFCs. So for that, we need to contact sometimes developers of Polkadot SDK. Sometimes we need to just really carefully read the Rust code and understand what's going on. And sometimes we see changes that's like they were just they're changing the Polkadot protocol a little bit. But then we realized that that was only the first attempt to implement some new feature, and then this initial approach is rejected, and then a new feature is implemented in the second way. So we really need to be in sync in order to in sync with developers from Parity, kind of to understand what's going on there. Going to conferences and just talking to developers is really helpful, just to understand their roadmap. Especially understanding what features are important to us, so that we can update them in a timely manner, so that Kagome is always up to date and compatible. it is also very helpful that recently, if you know that Polkadot SDK, they switched to more stable releases now, because previously they were releasing like every 2 weeks, for example, and that was very challenging. Like we see, okay, we have like a new release. We just implemented the features from the old release, and now we have a new one, so we need to catch up again. And now we have stable releases. I think the assumption is that they should be updated every 3 months or so. So this is really helpful. I think eventually what we need to achieve is something like what we have in Ethereum. So for example, where we have a huge upgrades like merge or Denkun, and everyone knows that, okay, this is the update, this is the bunch of EAPs that should be implemented. And different development teams, they kind of implementing that. So I think kind of like that we eventually will be in Polkadot, especially with now. I think now focus on multiple implementations of Polkadot node kind of increased with the announcement of GEM protocol, because now we have it is assumed that we will have multiple teams implementing the protocol. And the GEM will not be launched before we have multiple actually implementations. That was not the case with Polkadot in the beginning, because there was a huge rush in Web3 Foundation, as I understand. So they really wanted to kind of release and launch Polkadot as soon as possible. And the clients diversity was not as huge focus as it is now. And which is why, we still have just, I think, only Kagome client that is compatible and which is live in West End, in Kusama. I think things will be different in GEM, so where we have like more even distribution of multiple clients, hopefully.
Interesting. So is that the case that right now the sort of implementation of anything new is happening more centralized in that sense compared to what other chains do? Like, is that something that is a challenge?
That's a huge challenge. I mean, assume that in Ethereum, like we have a team who is developing the protocol specification itself, and then other implementations, they should follow and implement basically in their language. In Polkadot, we have like sometimes we have this situation when RFC and the ones who are implementing this RFC, they are basically the same people, and for them it's not as important to kind of communicate and convey for other implementers as well how certain features should be implemented. Things got much better recently. Now, whenever, for example, from Parity, a lot of guys, when they realize that some changes, they actually affecting us as another client development team, they actually opening an issue in our repo so that we support the newest feature as soon as possible. But it's not always the case, because sometimes for them it's just easier to implement something and then only create a document with RFC about this feature. So I think it's challenging. Things getting better, but I think we with kind of more increased interest to Kagome and other clients' implementations, especially considering that we're very close to launching Polkadot. I think things will be different, so that more communications will be happening between the teams. Implementations will be more aligned, and it will be easier for different clients, implementations team to kind of be up to date with the most recent upgrades of protocol.
Got it. So I thought the fellowship essentially with the whole RFC methods and everything was something done in this, but how are you finding that? Is that any help in sort of deciding where the protocol is moving towards?
We have some things that are kind of public and everyone knows that. For example, we had async baking and everyone knew that async baking is coming, so that obviously was a huge focus for us to kind of find as much resources as possible to how implement that. Then now we have elastic scaling, the same thing, which we also kind of know that it's coming, and we have first versions of elastic scaling already implemented in Kagome. But it's kind of Sometimes, yeah, indeed, changes just coming to Polkadot SDK in release, and we kind of realize that okay, that's now we have a new, for example, sync protocol, and there was no RFC for that. Sometimes that's happening, unfortunately. But yeah, in most cases, yeah, there is an RFC, and we see RFC is going through different stages. If we have an RFC, it doesn't mean that it will be certainly accepted. But as soon as we see some kind of endorsement from the other fellowship, especially fellowship members, especially with high rank, yeah, we realize that okay, that's the change that we should support, and that's something that we should start working on as soon as possible. Yeah.
Got it. Okay, so I want to sort of dial it down, and because most of our listeners are a little are a little too non-technical for us to understand. So I just want them to sort of, before we dive into Kagome itself, I want them to get a lay of the land, right? And I want you to sort of dive into what Polkadot, sort of what a host is and what a runtime is, right?
Yeah.
And then why is it not called a node and a host itself, right?
Yeah.
So yeah.
Well, yeah, it's basically called host because it is basically hosting the runtime. One of the outstanding features of Polkadot is that we have runtime that can be easily updated, and for us as host implementers, it's just a black box, and that really gives a lot of flexibility to Polkadot. For example, we do not implement the function that validates transaction or the function that executes the block. It is done on the runtime level. We just have very nice runtime APIs, and we just need to support. We just need to integrate one of the WebAssembly engine. In our case, we use Wasm Edge. I think Polkadot SDK is using WasmTime. We also kind of decided to use something different so that we have diversity. So if their Wasm engine has a bug, it doesn't affect Kagome and other nodes that also doesn't use WasmTime. That's for us as host implementers. Basically, we need to think about the runtime as a black box, which we can talk with, kind of to get some logic, for example, validating transaction, executing blocks, but also the runtime itself. It's talking with outside world because runtime doesn't have access to things like database, networking, also implementation of cryptography primitives is very slow on WebAssembly, so it's rather implemented on the host level. And for example, when during block execution we need to verify some signature, we're not doing this on the runtime level, but rather runtime accesses the host code. For example, in our case, it is written in C++, where we have implementation of some cryptography primitive, and then we return the result back to runtime. And for us, it was very challenging at the beginning, kind of just to be fully compatible, so that execution of the same block from Polkadot SDK on Kagome kind of gives the same result. And we can verify this result by comparing the resulting state roots after the execution. And so we really need to be careful and follow what's going on in Polkadot SDK, in RFC, so that if there is a new what we call host API, basically a new function that is implemented on the host level and what runtime can interact with. If it is introduced in RFC or in Polkadot SDK, we should support this as soon as possible, so that if we face the block where this new host API is used, we can actually execute this block. Otherwise, we basically end up with a situation where we just have an error because this host API is missing. So that's why it's called host, and hope it's more clear now.
Makes sense. So if that's the case, and you have to be, at your toes, making sure everything is sort of compatible and the interoperability in that sense sort of works, how do you test things? Like, what are your testing strategies to make sure that it's at par?
Well, in the beginning, Web3 Foundation itself had dedicated team that would work on testing compatibility among different implementations. Like as I told you, we have these host APIs, and they basically wrote a test, basically executing the same runtime logic, and that accesses different host APIs and checking that they return the same result in different implementations. Or Merkle tree, for example, another thing that also should be very carefully written so that it is compatible. So basically, Web3 Foundation was also helping a lot with that, so that they kind of created a test where we fill the Merkle tree with the same data among other, among different implementations, and then we check the Merkle roots that they are matching. That was in the beginning, and that's actually very similar to approach that we currently have with GEM test vectors, where we have basically data for example, for checking how SAFRAS, a new block production engine that will be used in GEM, how it's going to be used. So we have like different set of validators, set of data that we need to fetch into the SAFRAS consensus and check that the output is the same. So we really got a lot of help from Web3 Foundation, and we're getting that with things like GEM vectors for GEM implementation of the client. But then when our implementation got more mature, and we basically had all building blocks kind of working together, so we implemented transaction pool, consensus, for basically block production using Babe and Grandpa. Then parachain validation was a very challenging feature. When we had all in place, we were able to use a framework from Parity called ZombieNet.
And we have.
Yeah, and what they allowed us to do. Yeah, great. So they really made our life much easier. Well, in some sense, because now we have very convenient way to kind of check different scenarios and new features like, I don't know, async baking or elastic scaling. It's very convenient for us because, well, Parity itself, they are testing these features using ZombieNet. And what we can do is that, well, because ZombieNet is basically spinning up a network, we can easily replace some Polkadot SDK nodes with Kagome and check that the outcome of the test is the same. Because Kagome has identical CLI interface with Polkadot SDK. So if you're familiar with how to, for example, run validator using Polkadot SDK, you can just replace Polkadot SDK word in your terminal with Kagome, and you can run the node. So it's very convenient, and that allowed us to basically do the same in ZombieNet tests that we have in Polkadot SDK, so that we can just replace some nodes with Kagome and check how they would work with Polkadot SDK. Obviously that was convenient, but we also faced a lot of new issues, new incompatibilities that we had to check. Some of them they were obvious, some of them were not. Some of them were documented very well in Polkadot SDK, some of them not really. But even that, as we realized, was not good enough, because we have sometimes we have situations like, okay, things work perfectly on ZombieNet tests, but they break on West End. Then they work on West End, but they break on Kusama. So we hope that when everything will be working very stable on Kusama, we can launch it on Polkadot. Because, well, basically Kusama is, in some sense, it is more complicated than Polkadot, because in Kusama we have 1,000 validators. Last time I checked, I think Polkadot had just 300 validators. So if everything would be working fine on Kusama, it should work on Polkadot. We also have a new test network called Passio, which basically mimics the most recent runtimes and basically mimics Polkadot as much as possible. So we hope to launch there as well. So basically, we're speeding up as much test networks as possible, and testing Kagome in different environments. We're constantly syncing with networks like Passio, West End, Kusama, Polkadot, so that if we just syncing node, not the validator node, so that if, for example, we observe that some block cannot be executed, that probably means that we have some missing host API, or sometimes we see that Merkle root doesn't match, then we try to figure out why that is the case. we had a lot of such issues in the beginning. Now we don't have them.
Okay.
Yeah, but still we kind of having these test environments so that we can react as fast as possible for compatibility issues.
Got it. Got it. We actually had the ZombieNet team from the guys who are doing Gossamer, right? We had them
Cool.
on our podcast, and they did explain a lot about how they're working on ZombieNet. So yeah, it's an interesting tool, and I hope things sort of when it comes to testing standardize so that there's not a lot of effort that goes into just figuring out whether you're right or wrong, which is good to see. But yeah, I wanted to sort of dive into this part where you said sort of the variations in different uh, chains and how they react, right? So Kagome is a C++ implementation of the host itself, right? So and you uh, talk and you sort of are part of the like you're on the testnet plus the 1,000 validator program. So what challenges do you see going for Polkadot, right? Or sort of implementing the Kagome host implementation for Polkadot? Like, what are the challenges do you see happening?
Yeah.
Yeah.
Honestly, I think we can already just try and run our node on Polkadot. I mean, we are compatible, and honestly, some issues that we're currently facing in Kusama, they will not be the issues on Polkadot. For example, in Kusama, we have a very unique situation where we have like 1,000 validators, but not all of them are participating in parachains validation, and surprisingly, that actually causes some issues. In Polkadot, this is not the case, so likely, yeah, we'll be working more stable in that regard because. Yeah, in Kusama, because of this thing, yeah, that's one of the reasons why our node was not working very stable recently. And Kusama also has more validators than Polkadot. But in Polkadot, we have more things at stake. Basically, validators, yeah, they should be, if they are slashed, they really slashed very heavily. We hope this will not be the case with Kagome. And to ensure that well, basically, what we should to do is we need to convince our other node operators to actually use Kagome as their validating software instead of Polkadot SDK, right? And to give them confidence of running Kagome, yeah, we have few things. So first, we conducting the security audit, which is conducted by SR Labs team. They're basically the same team who is conducting the security audit for the Polkadot SDK itself. So they already know a lot of issues happened and fixed in Polkadot SDK, so they can come to us and request some changes. We already conducted the initial security audit. That was very helpful. For example, we introduced secure validator mode, which we didn't have before, which kind of allows to restrict the things that runtime can access, because runtime is the code that can uploaded by any user, and assuming yeah, it is voted on yeah, by the majority, yeah, it can in theory it was able to access some private keys from the memory, and we ensure that it cannot be the case in Kagome because of using the secure validator mode, and also storing private keys more securely. So yeah, that's one of the preconditions that we want to have, is to have security audit for every feature that we have in Kagome. Currently, with initial security audits, SR Labs team, they already covered most of the implementation of Kagome. But since then, we already introduced async baking, a lot of stuff related to elastic scaling, systematic chunks, basically the thing, optimization for how data availability works in Polkadot. And everything like that should be reviewed by the audit team, so that node operators, they have confidence of the software they are using. Another thing, yeah, we also want to have our node used in Kusama, at least by few node operators, so they can kind of test how it's working and maybe give some feedback to the community. Another thing which is very helpful is that, yeah, we're really feeling a lot of support from Web3 Foundation. For example, at some point, we believe they can support us in 1,000 validators programs in Kusama and Polkadot, so that people from community, they actually rewarded if they are using different client implementation than just Polkadot SDK, but they are also using Kagome or Gossamer or maybe some other implementations in future. That can really help a lot to bring clients diversity to Polkadot at a very important level, where when eventually we don't have majority of nodes running Polkadot SDK, so that if some bug happening to Polkadot SDK, we don't end up with, I don't know, bricked chain or thing when parachains cannot grow their blocks or anything like that. We really hope that we will be able to achieve all of that within this year. We're already getting started our second security audit, and we already implemented majority of features that is the most that we have in the most recent stable release of Polkadot, but we're already working on some new features as well. I think with our team, with support from community, with security audits, and also hopefully with some trust from node operators, we'll be able to kind of achieve clients diversity and finally launch on Polkadot. And then Polkadot will actually join club of very few blockchains where we actually have clients diversity. I think now we only have Ethereum. As far as I know, Solana is working on second client, but it is not ready yet. Filecoin got interested in also implementing different clients, but in Polkadot we're very close to actually achieve that. With projects like Kagome or Gossamer. So I hope this will be a huge success for us and for Polkadot ecosystem itself, because we're kind of getting into another level of security of the network.
Got it. So let's make the case for Kagome a little more stronger, right? Why not? Why don't we do that? Right. So let's talk about performance, right? How is it different, and how much does it impact the end node validators' performance requirements?
Right. That's actually another thing that I should have mentioned. I think we have to be as performant as other validators, and to do that, we have to understand. So basically, what matters for node operators is how much reward they are getting for their work, right? And that actually was also kind of field of research for us, because what we see in the beginning of each era, which is basically comprised of 6 epochs, we see how reward points they are distributed among validators, and then proportionally to how much reward points they received, they actually receive a proportional amount of DOT as a reward for their work as validators, right? Then we have to understand how these reward points are calculated. So it's basically 2 main things. First is we should produce blocks. So whenever we produce a block, we get some reward, even if this block is empty. But if we produce the block and convinced everyone that this block is valid and should be authentic, then we get reward for that. But the majority of reward points we get for actually validating parachains, to conducting the work of executing parachain blocks, because that's how Polkadot relay chain provides security. We basically execute the parachain blocks themselves, where we basically split our relay chain networks into the so-called backing groups, which execute the blocks of particular parachain, or should we say now of particular core, because it might not be necessary parachain now. And then we need to kind of then we eventually calculate how much work was performed by each validator, and proportionally they receive reward points, and in turn they receive dots as rewards for their work. So we're very good now in producing blocks right now with actually validating the parachains. We see some area for improvements. Currently, Kagome, if we just go to Westend, we see that it is a bit lagging with Polkadot validators, well, the validators that are running Polkadot SDK. And sometimes it's, we are fixing that, and we will fix that. Sometimes it's not obvious. why this is happening. Like
Okay.
it's not like when you're asking about performance, you might think about some optimizations or maybe some faster database or something like that, but it is not the problem with our databases or
Okay.
some other optimizations. Sometimes it's problem with just the protocol itself, and that's again we're getting back to the topic of how we should be notified of any important changes. Sometimes we see that, for example, things like reputation of the nodes is changing in Polkadot SDK. So Polkadot SDK introduces new rules of how to rank the nodes in the network. Yeah, so that they can understand which nodes are more important and who they should prioritize to send their messages to. And sometimes these rules, they are not obvious for us. For example, when we were working on grandpa implementation, we used a lot the thing called catch-up protocol, basically. Without going into details, it's actually very costly to just validator to respond with catch-up protocol because they need to collect certain proofs for blocks and then respond. So whenever someone performs catch-up in grandpa, Polkadot SDK node actually reduces the reputation of this node, so that if it actually abuses catch-up and uses it a lot, reputation is reduced. And we didn't know about that, and that's why we received less messages comparing to Polkadot SDK node, and which eventually led to less work by our validator, which of course reflected the error points and the rewards eventually. So we're fixing that. We already fixed a lot of reputation changes, like we have reputation calculation in grandpa protocol, we have them in parachains as well. So that's being improved already. There are some also other areas. I would say that networking is probably the most challenging stuff because we need to make Polkadot SDK nodes to basically send us as much messages as possible so that we can perform more work. We have capacity, we have huge capacity in Kagome to actually validate a lot of parachain blocks. But making Polkadot SDK nodes to kind of send all this data necessary for us to validate these blocks, it's very challenging. But when we actually can get full capacity, I think we can be very competitive. For example, one of the things where Kagome is better than Polkadot SDK is our erasure coding implementation. So erasure coding is needed to actually ensure data availability of the data that we need to validate parachain. Without data availability, we can end up with situation where we finalize some state of parachain, but we have no data to actually reproduce all transactions that can lead to this parachain. And if this data is lost, parachain can get stuck, and that's the end of the story. So we need data availability, and one of the cryptography primitives that is being used for that is erasure coding. So validators, they basically use erasure coding to distribute, to split data, to first extend this validation data, and then split it into chunks and distribute it among different validators. Among all validators in the network, basically. And in that regard, erasure coding for data is more performant in Kagome than it is in original Rust implementation. We compared and benchmarked it, and it's twice faster because we have really amazing people in our team who used to work in game development in the past, so they had to kind of squeeze as much performance as possible from any hardware. And we applied their knowledge to optimizing erasure coding, and it's really benefited us. So we observed that our erasure coding implementation is faster. I would say that we need to kind of follow the as you understand now, hopefully, being performant. It's not only about just optimizing some stuff, but also about making being fully compatible on protocol level and on the level maybe even below of protocol when we come to networking and these priorities and reputation stuff. We should be very compatible, and so that we can use every basically use our potential that we have in Kagome to basically validate parachains as much as possible, and then eventually get more rewards than we're getting now. Yeah, that's one of the areas that we're working right now, and yeah, that of course one of the preconditions for us to actually launch on Polkadot. Yeah.
Got it. So, okay, if that's the case, Kagome uses libp2p, right, for networking, right? So, can you dive into that? And I see that you also have implementation of libp2p in C++, right? So, can you also shed some light on that?
Yeah, well, when we were getting started with implementing Kagome, we realized that we need libp2p implementation, which we didn't have back then. So we had no other choice but implement it ourselves. That was also a bit hard in the beginning, but luckily we received huge support from protocol labs that actually responsible for the specification of libp2p. We had a call with them every week to ask any stupid questions, and I think that's actually very helpful to onboard people for the new protocols, just to allow them ask any questions and regularly just be accessible for them. So that helped us a lot. Eventually, we implemented C++ implementation of libp2p. I think it was also used by Filecoin node in C++ when we had it. Now we have basically our team is the team that is maintaining the implementation of C++ libp2p. I cannot say this is we're spending a lot of efforts on libp2p right now, because we implemented it to the level where it's enough for us to use in Kagome so that we are compatible with Polkadot. But if other people will start using it, maybe we will prioritize it more. There are certainly a lot of areas for improvement in this library. It's compatible, it's working, and it's being tested a lot, and battle tested already in Kusama, in West End, and so far so good. But we already have, it's 2024, and we have C++ 23 standard. So we can introduce a lot of new stuff from modern C++ to actually improve libp2p. But it's actually a question how much priority we should put into that, because I don't know if you know about that or not, but the gem will not use libp2p. There will be some different protocol for networking. I don't remember how it's called. It's exactly something like gem simple networking protocol, something like that. I don't think we have specification of that. There are some HackMD documents with some drafts of how it will be implemented. We don't have any details about networking in the gray paper. But from what I see, libp2p is not going to be used in gem. So we can. For us, it's a huge question for us, honestly. How much efforts we should put more in libp2p? We have. We hope. We'll support it more. We already introduced Quick recently. It's basically Quick is a security protocol that will be used, for example, in gem, and now Kagome supports Quick. So basically, I don't remember if Polkadot SDK have Quick implementation in libp2p, but if they not, then that's another advantage of using Kagome, because it's a modern protocol.
Nice.
So that's that's about
nice.
libp2p.
Interesting, right? Okay, so I wanted to talk about how these new changes, you talked about jam a bit, right? So I will dive into jam a little later, but just want to sort of get started with all the new stuff that has currently been done, right? So you've recently applied for a new proposal, and you said asynchronous backing and Beefy and the new Awesome engine that has been included in this, right? So I wanted to understand what asynchronous backing is from you, and how have you sort of decided to, and what were the challenges implementing it in a Polkadot host?
Well, for async backing, it's basically an optimization. What we had before async backing is that we have these 12 seconds of parachain blocks, right? So we need to first relay chain block is used to basically give some time for this baking group of relay chain validators assigned to particular parachain to execute this parachain block, perform some voting inside this group, and basically then endorse this parachain block.
Okay.
But that's not enough, because now we need to do another thing, is ensure data availability. And this is why we have second relay chain block slot, so that we have enough time to distribute Razor coded pieces that I described before, that contain this data necessary to basically execute this parachain block among all relay chain validators. So we needed two blocks of relay chain block, two relay chain blocks to execute single parachain block. That's why we had 12 seconds. With async backing, we don't have this restriction anymore. As soon as we send our parachain block to our backing group of relay chain, we then this group actually validated it. Then parachain can already supply second block without waiting for inclusion, or inclusion is the process of ensuring data availability. And that's how we can actually execute more parachain blocks faster. And we don't have this requirement of 12 seconds anymore. It's coming with challenges, of course, because we have to take into account that we're using BAPE in Polkadot, and the BAPE is block production algorithm that actually allows forks. So we can end up with situation when certain relay chain block endorsed one parachain block, another block, another relay chain block endorsed another block of parachain, and then we have to figure out, we basically need to store multiple states of these parachain forks as well inside the relay chain validators. Yeah, that's maybe sounds complicated, but implementing that is also very, very complicated for us.
True.
Yeah, so that was challenging. But eventually, we implemented that. Now it's compatible. We see our async baking is working on Western. We're passing all ZombieNet tests. Hope I shed some light on that.
Yeah, no, that's great. That's great. So, Babe, right? So I wanted to talk about SASFRAS, which is essentially the new sort of block production protocol that has been sort of introduced. And what are your thoughts on that, right? Is it any beneficial? From what I see, I feel that it should probably improve that empty block production and rewards, right? That should not happen, because this whole ZK snark protocol that's there in the new production protocol. But I wanted to understand from you, like, how do you see that as the advancement to BAPE?
Yes, well, that's a very important advancement. So as I said before, what we can have in BAPE is basically the situation where we have either no block producer at all, or where we have single block producer, or we have multiple block producers. And because of how we elect the block producer itself. And what Polkadot is doing is that when we have no validators that were elected with BAPE, we just elect a validator using round robin fashion, just basically putting them into clock and performing modular operation to decide who is the next validator. And that's very bad, because the main why we needed BAPE, why we just couldn't use this round robin fashion, is because with BAPE we actually it's impossible for any attacker to kind of understand that who will be the next block producer, so that they can put all of their resources to attack this particular block producer, so that they cannot include a lot of transactions and perform a lot of work and maybe validate parachains. So that's bad, and we need to avoid that. That's why we have BAPE, which gives this unpredictability. But unfortunately, with this unpredictability, we also get this property that we might not necessarily have just a single validator producing a block. SASFRAS is solving this problem. SASFRAS is what we call single secret leader election algorithm that actually uses some ZK primitives to ensure that we only can have single validator. And this validator, no one can understand in advance who exactly this validator is going to be. And this is achieved using the crypto primitive called ring VRF. So in contrast to VRF, where we just produce some, every validator just trying to produce some random value with some deterministic randomness, and then they kind of comparing their value with threshold, and if they satisfy this threshold, they are allowed to produce a block. In ring VRF, it does all the same, but with huge differences that there is no way to check who exactly produced this random value. And with that, we actually can, validators can use ring VRF to generate tickets with these random values. Then we shuffle them deterministically. And for the next epoch, we can already assign each ticket for each slot. And then whenever the slot begins, validators, they understand, okay, it's their turn because the ticket that they have in this slot is actually correspond to them. So now they send the proof to everyone that they are the ones who actually produced this ticket, and everyone else, they can accept this block. With this approach, we reduce, there are still some edge cases when forks can happen, but they're very rare, and they can only happen when, some validator is, just, they had their ticket, for example, for slot, but they didn't produce block in time. So I don't know, maybe they had some networking issues. But in most cases, we can assume that we will have only single fork. And that gives a lot of advantage for us. So we can optimize different stuff. As I said previously, with async backing, it's very complicated of keeping track of every possible parachain blocks, because we might have different forks on the relay chain. Yeah. Now it's easier. So we have just a single leader who decide what will be the next block, right? Another not very obvious optimization that we can do is actually optimizing performance of our runtime, because what runtime is doing is it's reading data from the disk. So the data itself, basically our state is stored in the structure called Merkle tree, and accessing this the data from this structure directly is actually, it's not very optimal because it's obviously a tree. So we need to follow a path from one node to another node, and that's actually a lot of disk accesses. And with SASFRAS, we can have only single fork, optimistically again. So we can assume that we have only one fork, so we can just mimic all the data that we have in our Merkle tree and store it in some key value database where we can access this data with constant complexity and ensure that this data is it is the same data that we have in Merkle tree, because if we had forks, recreating this data in key value storage could be very challenging. Because we can have only single storage with key value data, but if we have forks, we need to have multiple storages. That's not very good. When we have just a single fork, we have single storage. Of course, we should have some mechanisms to actually rework to some other forks if we have this situation, but this case is very rare. So optimistically, we can assume it will never happen, but still we are ready. We know techniques how to do that. And that's another advantage here. So basically, reading the disk and executing runtime can get much faster with SASFRAS. Yeah.
Got it. Interesting. So I feel all of the new changes, including the async backing and SASFRAS, so they are sort of helping Kagome sort of be better optimized and sort of be in a much better state, even though like there is a lot of code that probably is going to be removed, but I feel this is in a good direction that where we are going. Interesting. So then I think Jam is the next thing that sort of is coming up, right? And I wanted to understand what are some of the challenges that you anticipate while building a Jam client because I saw the proposal itself, and you mentioned that your focus is currently on Kagome because you feel Jam is a little later on. But how are you focusing on making sure that you are ready for whenever that happens?
Well, answer is simple. We just do the same thing that Party is doing. So
Okay.
when I just heard the announcement of Jam, yeah, of course that was a huge surprise for us. We Because the way we funded through community, so they
Uh,
support our treasury proposals, and we kind
yeah.
of instantly thought, wow, now they might ask us questions like, why do we need Kagome? Now we have Jam, right? And
Mm.
yeah, I talked with a lot of guys from Parity, like Pierre, VP of Engineering. I was able to talk with Gavin about that, and just to understand what is the approach on the Parity side of how to implement both Gem and still maintain Polkadot SDK. So we decided to do the same, which is as we see now, still the majority of Parity developers, they are working on Polkadot SDK, just finishing with stuff like elastic scaling, optimizing data availability, and so on. And only just a small portion of Parity is actually working on Gem. Well, I think eventually, as I understand it, will get larger and larger, and more people will get involved in that. And that's basically, we will do the same, because as long as Polkadot SDK is supported and new features are introduced there, we need to do the same so that Kagome is compatible, because we want to bring clients diversity before actually Gem upgrade is happening. And as we realize and as we see now, it will likely not take, I don't know, my assumption within next 2 years, we most likely will not get Gem upgrade. So, and with Kagome, we are planning to already run our validator in Polkadot this year. So we have clients diversity in Polkadot already. So that, and 2 years is very huge period. A lot of bugs can happen. And with Kagome, we can reduce probability of bugs that can actually break the network. And we're very close because we already have the node that is running on West End, which is running on Kusama. So we thought it doesn't make sense for us stop working on Kagome because we're so close to launch on Polkadot. And because Parity is still maintaining Polkadot SDK, introducing a lot of features there. But of course, yeah, we're paying attention to what's going on with Gem. We following what's going on in Gray paper, and we also there are already publicly provided Gem test vectors for example, binary Merkle tree implementation for Gem, or SASFRAS, or recently I think there were some first tests for PVM already, and we're trying to support them as soon as possible. For example, for binary tree, we already have tests passing on our side. Yeah, we have guys who were working on that. Then for SASFRAS, the same. We already have passing tests for SASFRAS test vectors. Yeah, for PVM, yeah, we're just getting started there, but I believe, we'll get there as well. And then, when we see that Parity is not focusing on Polkadot SDK anymore, they're just maintaining it, we'll do the same. So that means that they switched fully on working on Gem. And I believe, we will be on the same conditions. So when they switch to working fully on Gem, we'll do the same. Otherwise, we might end up with a situation when we have Kagome almost implemented, but there are some very few new features introduced into Polkadot SDK that make it incompatible. I thought, well, we have a project that we've been working on for more than 5 years. It doesn't make sense for us to stop just because of that, considering how close we are to launch on Polkadot.
True.
Yeah.
Definitely. So, I think you talk about a lot about the diversity in the Polkadot client implementation. Why do you think that's necessary, right?
Well, just go into history of Polkadot and Kusama, and we see that sometimes we had a case when, in Kusama, I think we had situation when parachains just stopped producing blocks because some disputed block of parachain had finalized for some reason, and that happened because of bug in Polkadot SDK. Or in the very beginning of Polkadot. I think in the very early days of mainnet, there was also a situation when a new client upgrade of substrate actually led to issues, and network couldn't produce new blocks. Or most recently, there was actually a fix into Polkadot SDK that allowed to stall the network during rework. Well, not stall the entire network, but the one particular Polkadot SDK node might stop to finalizing blocks because of rework and because of just a simple bug in the code.
Okay.
Just to avoid these situations, we need to have clients diversity. So probability of such bugs is as less as possible. As I said, we are trying to kind of follow the specification when we have one, to implement a feature based on specification. For example, Grandpa, we implemented just looking at specification without following what's going on in the Rust code. Just at the very end, we checked for compatibility, implemented the same unit tests, and that's it. And because of that approach, we didn't have this issue with Grandpa that I mentioned earlier. And if we had already Kagome, this bug, it would not be issue at all. So we just might have the situation when, some part of the network, they cannot, produce blocks or finalize blocks, but still network is live. So we can have second client that is alive and still can, work in the network. So that's one advantage. Another advantage is that we're actually extending the development community that is working on Polkadot protocol. Because with Polkadot SDK, we just only have Rust developers. And with project like Kagome, we can take advantage of developments happening in C++ community, because C++ obviously is very widely used language by many people. There are a lot of libraries, especially in crypto, written in C or C++, which we can easily integrate into our project. We can have we have a huge choice of different tools that we can use. For example, which WebAssembly engine to select in Kagome. Now we use Wasmatch. Previously we used Binarian and Wavum. So we can really take advantage of that, and that's really nice. And another thing is that when we have just a single team working on the project, that's they are rushing. As I said previously, sometimes it takes multiple attempts to implement certain features. So they have first take, second take, and so on. For us, we see the end result, how certain things should work. And we can take advantage of that by implementing things in the most optimal way. As I said, we realized, we can improve Azure coding. Why not? And we did that. The same, we can just, if some feature was introduced into, for example, Rust first, we can take a look and check some pain points and realize some stuff we can improve and make it better. That's why we need clients diversity. And we also can have more expertise, not only in a single company that understand how Polkadot is working, but in multiple companies. So we have now Quadrivium, we have ChainSafe, who understand very deeply how protocol is working. And we can give our opinion, how certain features should be implemented and whether some upgrades are they secure or not, and so on.
Interesting. Nice. Okay, so I want to sort of close up with a few questions around the project itself. And how can other developers get involved with Kagome, right? What advice do you have for them?
Well, first of all, just give it a try. And try to spin up, for example, sync network, syncing node, for example. And we're fully compatible with Polkadot.js, for example. Recently, I was testing Nova wallet with Kagome as well. Now Nova has a feature to select the node, and I checked we can connect Nova to Kagome, and it's working. So nice. Give it a try. Maybe you realize that some RPCs are faster. I don't know, it's not necessary if you're node developer, but if you're, for example, wallet developer or front-end developer, you can still use Kagome. And we have small team, but that also means that we're faster to react to certain issues. So if you realize, I don't know, some RPC should be faster, you can just create an issue in Kagome, and we can take a look. And if indeed that's very important for you as, I don't know, a blockchain explorer or something, we can optimize for that. We have capacity for this, I believe. Next, of course, if you are node operator, you can give it a try running Kagome instead of Polkadot SDK. Just at least before we're fully ready, before we pass the security audit, at least give it a try to check how it's different, how to build Kagome, how to run it. As I said, we try to make it as simple as possible so that we have the same command line interface, so you can just replace Polkadot SDK with Kagome. Maybe you then find some bugs and maybe some issues that we didn't realize because we are developers. Maybe for us something is obvious and for others it's not. Just create an issue about that. We'll try to fix that. So I think that's one of few ways how to get involved. And of course, our implementation of Kagome is fully open source as well as Lippy2P. So if you want to have some feature and you believe you can integrate it yourself, you can do that. I can say, for example, in Lippy2P recently we introduced Quick. It was developed first not by us, but some person from open source community just integrated Quick into Lippy2P. We took a look. We made some changes on our side, but a lot of things they were taking just from original proposal from community, and that was very helpful. So anyone can do that with Kagome too.
Interesting. Okay. So, final question, right? So, what are your thoughts on the future of the Polkadot sort of developer experience, and how do you see that improving?
Well, that's a tough question for me, I think, because developers, there are different kinds of developers, right? We have runtime developers, we have node developers, we have, wallet front-end developers. I understand. I know very few, honestly, about runtime development. We are just hosting runtime. We're treating it as a black box. But from perspective of node developer, I hope that in future, it will be more easier to kind of keep track of changes that are coming to the next Polkadot release, so that teams, they are aligned. So basically the things that we have in Ethereum when we have test networks, where we ensure that multiple client implementations are actually compatible, they can work together, and only then they are releasing it to the mainnet. With Gem upgrade, this is what I see we will have in future, because Gem will not be launched unless we have, as far as I remember, 3 fully ready, audited and performant clients implementations. We should actually understand that with clients diversity approach, some stuff, they will come slower, at slower pace, because now, as I said previously, we have same people who come up with some protocol changes and who actually implement that, and now they have additional step of coming up with new protocol changes. Then they need to communicate it with everyone else, agree on that, and only then implement. So we should understand that it's challenging. In the beginning it will be very painful, but hopefully at some point everyone will get used to that, and we'll get all the benefits that we can get from clients diversity, which I mentioned previously.
That has been a really great episode, Kamil, and I hope everyone who's listening have a lot to learn and understand what it takes to build a custom implementation for Polkadot host. Right? If you enjoyed, please don't forget to like, share, and subscribe the AwesomeDOT Podcast. And until next time, this is Yogesh signing off. Thank you.
Yeah, thank you.
Thanks for tuning in to this week's episode of AwesomeDOT. We'd love to hear your thoughts on this episode in the comments section or at website. The content presented on AwesomeDOT is not financial or investment advice and should not be viewed as a recommendation to support any specific project. The views expressed are the personal opinions of the podcast guest and moderator and may not necessarily be shared by AwesomeDOT. We do not endorse or guarantee the accuracy of the information provided. Want to join us as a speaker? Visit our website at awesome-dot.com to learn more. Remember to star the GitHub repo, awesome-dot. Also, you can always find us on Spotify for more great content. Have a great day. See you in the next one. Thank you.